Hello, my dear children. Welcome to the mathematics class. Now we are going to discuss complex numbers and quadratic equations. Okay, my dear children. In this chapter, we have already discussed the concepts of exercise 5.2. Now we are going to discuss the problems in the exercise 5.2. Page number 108 in the textbook. Page number 108 in the textbook. Are you ready to listen the class, my dear children? Right. Now come to the question number 1. First question. Find the modulus and argument. Sometimes it is also called amplitude. Okay, my dear children, remember this terminology of the complex number z is equal to -1 minus I root 3. Understood this question, my dear children? What is given? A complex number is given. And what are asked here? We have to find the modulus of this complex number and argument of the complex number. Okay, my dear children? Right. Now come to the solution part. First we have written the given complex number z is equal to, generally this is the standard form we have already discussed, x plus iy or a plus ib. We can write as per our convenient. Okay, my dear children? So I wrote here x plus iy is equal to -1 minus I root 3. Understood this step, my dear children? Right. This implies z is equal to, I am writing this complex number in the form of Cartesian coordinates ordered pair x comma y. In the beginning of this chapter we have discussed that point. Every complex number can be represented an ordered pair of real numbers. Okay, my children? The real part can be written as x coordinate comma imaginary part can be written as y coordinate. Do you remember these points, my children? Right. That is equal to, here also we are writing this complex number in the form of Cartesian coordinates. So -1 comma minus root 3. Understood this step, my children? So what is the value of x here? -1. What is the value of y is equal to? minus root 3. Because these two ordered pairs are equal. If two ordered pairs are equal, we have to equate the first components. Means x is equal to -1, and at the same time we have to equate the second components, that is y is equal to minus root 3. Understood these points, my children? Right. Now come to the point modulus of z. How do you denote modulus of z? This is a notation, modulus of z, and generally we use a small letter r. In this chapter complex numbers, small r denotes modulus of a complex number z. Remember this point also, my children. Small letter r denotes modulus of a complex number z. Okay, my children? R is equal to formula square root of x square plus y square. R is equal to square root of x square plus y square. This is a formula for finding the modulus of a complex number. Okay, my children? In this formula we are substituting x and y values. Square root of, what is x value? -1 whole square, plus what is y value here? minus root 3 whole square. Understood this step, my children? We substituted x and y values in this formula. Okay, my children? Right. This implies r is equal to square root of -1 whole square. What is the value of -1 whole square? 1, plus what is the second term here? minus root 3 whole square. What is the value of minus root 3 whole square? 3. Understood this step, my children? Right. That is equal to square root of, what is the value of 1 plus 3? 4. Understood this step, my children? Right. Square root of 4. What is the value of square root of 4? 2. Okay, my children? Right. So r is equal to 2. That is modulus of the complex number z is 2. Therefore modulus of z is equal to r is equal to 2. The first part of the question is over. We have found the modulus of the complex number, that is 2. Understood this part, my children? Right. Now come to the second part. What is the second part? We have to find the argument or amplitude of the complex number. To find the argument or amplitude of a complex number, we have to write sin theta, cos theta and tan theta values first of all by using these formula. Okay, my children? Remember this formula, my children, to find argument of a complex number. to find the amplitude of a complex number, we have to write cos theta is equal to x by r, and sin theta is equal to y by r, and tan theta is equal to y by x. We have to write these three equations. Okay, my children. Right. This implies cos theta is equal to, what is x value? -1 by, what is the value of r? 2. We have already found here. So -1 by 2. Understood this step, my children? Right. And sin theta is equal to y by r. What is the value of y? -√3 by, what is the value of r? 2. Understood this step, my children? Right. And tan theta is equal to y by x. What is the value of y? -√3 by, what is the value of x? -1. So -√3 by -1. That is equal to, by simplifying these terms, these numbers, what will you get finally? √3. This implies tan theta is equal to √3. Tan theta is equal to √3. Then what is the value of theta? Pi by 3. Isn't it or not, my children? Theta value is pi by 3. Okay, my children. Like this, we have to find the value of theta. But this is not said to be argument of z. This is not said to be amplitude of z. Okay, my children. Some more portion is there. Some more part is there. What is that part? We have to identify the position of the complex number in the organ plane. Means in which quadrant the complex number lies. See here, -1 comma -√3. It lies in the third quadrant. Okay, my children. If the complex number lies in the first quadrant, theta value is that only. This is argument of complex number. If the complex number lies in the second quadrant, then the argument of z is pi minus theta. From this equation we find theta. After that we have to follow these steps to find the argument of complex number or amplitude of the complex number. Okay, my children, remember these points. If the complex number lies in the third quadrant, then the argument of z is equal to theta minus pi. Okay, my children. If the complex number lies in the fourth quadrant, then the argument of z is equal to minus pi. Remember these 4 points, my children, to find the argument of a complex number or argument of a complex number. Okay, my children. Right. So before going to find the argument of complex number or amplitude of the complex number, please remember these 4 points, my children. First point, if the complex number lies in the first quadrant, then argument of z is equal to amplitude of z is equal to theta. I have shown diagrammatically here. The complex number lies in the first quadrant, then argument of that complex number is theta only. Okay, my children. Right. Second point, if the complex number lies in the second quadrant, then argument of z, that is equal to amplitude of z is equal to pi minus theta. Here I wrote here pi minus theta. This is the argument of z or amplitude of z. Understood this point, my children? Right. Now come to the third point. If the complex number lies in the third quadrant, then argument of z, that is nothing but amplitude of z, is equal to theta minus pi. I wrote here theta minus pi. This is the argument of z or amplitude of z, theta minus pi. Okay, my children, understood this point, my children? Right. Now come to the fourth point, last point. If the complex number lies in the fourth quadrant, then argument of z, that is equal to amplitude of z is equal to minus theta. Understood this fourth point, my children? Here minus theta, I wrote here this box. This minus theta denotes the amplitude of the complex number or argument of the complex number. Okay, my children. Now come to the given question. Here the given complex number lies in the third quadrant. Here -1 comma -√3. So this point lies in the third quadrant. Then what is the argument of z or amplitude of z? Theta minus pi. We have already found the value of theta. Okay, my children? Right. So pi by 3 minus pi. We have to substitute the value of theta in this formula. Theta minus pi. So here this is the argument of z or amplitude of z. This is the formula to find the argument of z or amplitude of z if the complex number lies in the third quadrant. Okay, my children. So pi by 3 minus pi. Now we have to simplify these two numbers. So we have taken the LCM of the denominators. Then denominators are 3 comma 1 only. So LCM of 1 and 3 is 3. Then what will you get in the numerator? Pi minus 3 pi. Understood this step, my children? Right. That is equal to, in the numerator, what will you get? Minus 2 pi by 3. This is nothing but argument of z or amplitude of z. Understood this point, my children? I am not explaining the question number 2 because it is same as that of question number 1. Will you try yourself the first question, second question, my children? Okay, right. Now come to the question number 3. Question number 3. Okay, my children. Because I am not explaining question number 2 because question number 2 is same as that of question number 1. Try the question number 2 yourself. Okay, my children. If you have any doubts, ask your doubts and get your doubts clarified. I will help you in solving the question number 2. Okay, my children. Now come to the question number 3. In this Roman, all the questions are of the same type. Okay, my children. Total 3, 4, 5, 6, 7, 8 questions. From question number 3 to question number 8. We follow the same steps. We follow the same procedure. Okay, my children. Please listen these steps. Listen this procedure carefully, my children. I don't explain the remaining questions. Okay. Question number 3, I will explain the question number 3. You try the remaining questions yourself. Okay, my children? Right. See, before solving the question number 3, you should note this point. Let z is equal to x plus iy be a given complex number. Then polar form of the complex number z is equal to r into cos of argument z plus I sin of argument z. This is nothing but the extension of the question number 1. In the question number 1, we have found modulus of the complex number, that is we found r value, and argument of the complex number we have found. After finding the two values, just we have to substitute in this formula. This is nothing but the polar form of the complex number. That's all. Nothing else. After finding the modulus of the complex number and argument of the complex number, just we have to remember this equation. We have to remember this formula. This is the polar form of the complex number, r into cos of argument z plus I sin of argument z. Okay, my children? Right. Where r is equal to square root of x square plus y square. Okay, my children? Right. Now let us take the given question. What is the given complex number? 1 minus I. So z is equal to x plus iy is equal to 1 minus I. Understood this step, my children? Right. This implies z is equal to, I wrote this complex number in the Cartesian coordinates. Ordered pair x comma y is equal to, what is the real part? 1. 1 is written as x coordinate, comma. What is the imaginary part? Minus 1. I told you many times. Coefficient of I is considered as imaginary part. So here minus 1. Understood this point, my children? Understood this step? Right. Therefore, r is equal to formula x square root of x square plus y square. We are finding the value of r by using this formula. Understood this step, my children? Right. In this formula, we substitute the values of x and y. Square root of 1 whole square, x value is 1 whole square, plus what is y value? Minus 1 whole square. Understood this step, my children? Right. That is equal to square root of, what is the value of 1 square? 1, plus what is the value of minus 1 whole square? 1. Understood this step, my children? Right. Is equal to square root of, what is the value of 1 plus 1? 2. So this is the value of r. Okay, my children, we found the modulus of the complex number r. Now we are going to find argument of the complex number. Before to that, we have to find the value of theta. First we have to find the value of theta. So tan theta is equal to modulus of y by modulus of x. Remember this point, my children. Modulus of y by modulus of x. To find the value of theta, use this formula. This implies tan theta is equal to modulus of, what is the y value? Minus 1 by modulus of x value is 1. Understood this step, my children? Right. That is equal to modulus of minus 1, 1 by modulus of 1, 1 only. Understood this step, my children? Right. This implies tan theta is equal to 1 by 1. What will you get here? 1 only. This implies tan theta is equal to 1 can be written as tan pi by 4. Isn't it or not, my children? Right. So, what will you get here? Theta is equal to pi by 4. Like this, we have to find the value of theta. After that only, we go to the argument of z. First, we have to find the value of theta. After that, we find the argument of z. Okay, my children? Right. Now, if you observe this diagram, if you plot the complex number in this argand plane, it lies in the third quadrant. Understood this point, my dear children? So here the given complex number lies in the fourth quadrant. In this fourth quadrant, it lies in the fourth quadrant. Therefore, argument of z, it is nothing but amplitude of z is equal to minus theta. In the first question, we have discussed the positions of the complex number in the argument in the different quadrants and their amplitudes. Okay, my children, recall that previous knowledge. Minus theta, that is equal to minus, what is the value of theta? We got here pi by 4. So minus pi by 4 is the argument of the given complex number. Understood this step, my children? Right. So we got here r value and argument of z also. Therefore, polar form of the complex number z is equal to r into cos of argument z plus I sin of argument z. Remember this formula, my children, for writing the polar form of a complex number. That is equal to, what is the value of r? Root 2 into cos of, what is the argument of z here? Minus pi by 4. Cos of minus pi by 4 plus I sin of argument of z minus pi by 4. Understood this step, my children? Next we have substituted the values of r value and argument of z in this step. Then we got this step. Understood this step, my children? Which is the required polar form of the given complex number. Understood, my children? Right. So with the help of this knowledge, can you try the question number 4, question number 5, question number 6, question number 7 and question number 8, my children? Try yourself these questions by following these procedure, by following these steps. Will you try the questions, my dear children? Right.